Alright, let's have a look at one more question. Graphs of functions, inverse functions. We are given here the sketch below represents the inverse of f of x is equal to ax squared. I must be very much careful because the graph that is given here is the graph of the inverse. It's not the graph of f. It is the graph of the inverse of f. Look at what they are asking now. Give the coordinates of one point where both graphs are passing. Now, in the previous sections, we have explained that in f of x is equal to ax squared, if a is a positive number, then we expect that your graph goes up to the positive and the inverse goes to the positive as well. Both of them pass through the point 0, 0. So the answer for question 1 is 0, 0. They both pass through 0, 0. Number 3.2. We want to find the equation of f. Once again, be careful. The details we have in the diagram are that of the inverse of f, but the question wants us to find the equation of f. So we know that when coordinates are given on the graph, we can substitute those coordinates into the equation of the function. If the inverse is passing through 4, 1, it means the original graph is passing through 1, 4. So that means in this equation of f, we can use the coordinates 1, 4 to calculate the value of a. So substitute normal algebra. A is equal to 4, therefore f of x is equal to 4x squared. Number 3.3, this one is basic algebra. So in the equation of g, just take notice that in this case we don't have the equation of g. We may have to find g first before we do anything. So from y is equal to 4x squared, g is the inverse. So you swap x and y, that will give you x is equal to 4y squared. Then we divide by 4 both sides, and that will give us 1 over 4x is equal to y. Then we square root both sides to give us y is equal to the square root of 1 over 4x. This is the equation of g, the inverse of f of x. Now if we say g of x plus 2, it means in the equation of g, you remove that x there and you replace it with x plus 2. So x over 4 becomes x plus 2 over 4. Now, so we now formulate an equation. This is equal to 16. Therefore, we're going to equate this to 16. Now we can solve the equation. X plus 2 over the square root of x plus 2 over 4 is equal to 16. This 16 is 16 over 1. Then we can complete our equation. If we cross multiply here, we're going to have, we can't cross multiply because there is a square root. So basically, we have to square both sides. This side square, that side squared to get rid of the square root. So it will give us x plus 2 over 4 is equal to 256 over 1. Then we cross multiply to get x plus 2. It will be x plus 2 is equal to 4 times 256. That will give us 1024. Then you move the x to that side. It will give you x is equal to 1024 minus 2. So x is equal to 1022. That is the answer for number 3.3. Then number 3.3 is. Then the next one is number 3.4. That is sketching the graph. So let's go ahead and see how to go about that one. Number 4, drawing the graph. Remember from our previous discussions, we said the coordinates x, y, they become yx when drawing the graph of the inverse, which means in our case 4, 1 will become 1, 4. 16, 2 will become 2, 16. Then we connect them to produce the graph of the required graph of the function f. That's what we are doing in this case. On the part of drawing graphs, it might be necessary to emphasize that we have said given f of x is equal to ax squared, we have different scenarios here. If a is a positive number, your graph will go upwards to the positive side. That is how my graph looks like. Then if the domain is limited, that means if x is an element of, let's say, 0 to positive infinity, then when you draw the graph, it's going to be only half of the parabola on the positive side. Now, if I want to construct the inverse, if the graph is going to the positive sign, the inverse will also go to the positive side. That's what we have said. Now, if you look at my second diagram where the domain is restricted, I've just drawn half of my parabola. The inverse will also be only half of it. It will only be half. This is the inverse. So I must start in such a way that I've got clarity on what is going on here. If the domain is limited, that is in f of x is equal to ax squared, then x is from negative infinity up to 0. Should we get something like this? And if a is negative, then we're going to say that our graph will be on the negative side. This is the full parabola with no any restriction. Then the inverse will also be full on the negative side. But if the domain is restricted, like it is here, from negative to positive infinity, then we expect our graph to be, it's from negative infinity to 0. We expect it to be just a piece like this. Then the other one will also be a piece like that. So that will be my function and its inverse. Please start this section. We have made a number of videos that are explaining the same thing. So number 3.4 is answered. The graph is drawn. The relationship between the two is that one graph is a reflection of the other along the line y is equal to x. That is my answer for this question.